All right, let's dive right into this. Welcome to today's explainer, where we're going to unpack something truly fascinating. Imagine we're looking at a complete architectural blueprint, but instead of a building, it's a blueprint for a brand new physical framework. We are analyzing the Osomechanical Theory today. It's a model that's proposing a massive paradigm shift in how we understand the very mechanics of the universe. So think of this explainer as a grand tour of that master blueprint. We're going to examine the foundation, check out the building materials, and then we'll put the whole structure through a rigorous mathematical stress test to see if it actually holds up. To kick off our tour, I want you to really think about this one profound, paradigm-shifting question: what if space-time isn't fundamental, but actually emergent? Like, what if the universe isn't just sitting on some static geometric grid, but is instead built entirely from dynamic, tension-filled connections? It's an incredible thought, right? Let's see how this theory attempts to prove exactly that. Here is a quick roadmap for our explainer today. We're starting with the universe's hidden structure, moving into Phase 1, covering the foundational postulates, Phase 2 on constants and units, and Phase 3 for the dimensional stress test. Then we'll wrap up by looking at the dimensionless constant and what lies beyond Planck units.
Okay, let's get into Part 1, the universe's hidden structure.
Moving right along to Phase 1, the foundational postulates. So this is our theoretical blueprint. Any strong theoretical physics model needs a rock-solid foundation, and the entire Osomechanical theory rests on just 7 distinct principles. The very first one is a massive shift all on its own: connectivity. The theory argues that the universe is a dynamic, tightly drawn, connective structure. Everything we interact with, mass, energy, momentum, it all appears as a direct result of the tension within that structure. You'll also notice principles like unified relational action, which basically means physical action is just the transfer of this connection, and velocity limitation, which totally reframes the speed of light as the absolute hard limit for how fast tension can actually transfer through the network.
And this brilliantly illustrates one of the absolute most crucial shifts in perspective here: emergent geometry. In this model, space-time isn't the primary stage where things just happen to take place. Instead, space-time itself emerges as a direct result of how that osomechanical tension is distributed. It's wild to think about, but the cosmic stage is actually created by the tension of the connections within it.
Now, to keep this whole structure stable, the second postulate introduces a maximum tension limit, F sub O equals C to the fourth over G sub M. You can think of this formula as the universe's built-in safety mechanism. By capping the maximum tension allowed in nature, it actively prevents infinite structural collapses and naturally enforces the speed of light.
But here's the really cool part: things aren't just arbitrarily limited. That brings us to relational quantization. You know how in standard physics, quantization is often this external rule that's just kind of applied to the math? Well, here, quantum behavior arises completely naturally from the structural balance and equilibrium within the connections themselves. It isn't forced in. It simply emerges right out of the ratios of connectivity.
All right, that brings us to Phase 2, constants and units. Now we get to gather our materials and give this theory some real-world scale. Meet the massive central constant of this entire theory, G sub m. Its value is roughly 1.514 times 10 to the 29th power. To put that into perspective, that is a literally staggering amount of force. And hey, while it looks a bit like Newton's gravitational constant, big G, they're vastly different. Newton's G describes distant macroscopic attraction. G sub m, it's an immense, multi-scale structural binding constant. It describes tension on a fundamental, core level. From that central constant, the theory organically derives a closed system of reference units for mass, length, time, and energy. What is absolutely vital to understand here is that these aren't just random numbers pulled out of thin air. They are derived directly from unifying quantum action, Planck's constant, with the speed of light, and our new binding constant, G sub m. So why does all this matter? Because these derived units perfectly align with actual observable nuclear physics. Look at that reference energy, 256.33 MeV. That is incredibly close to actual nuclear and baryonic binding energies. The reference density matches standard nuclear density. The math directly scales to the Compton lengths of protons and neutrons, and it perfectly approximates the Bohr radius. It is beautifully physically connecting the electron, proton, and neutron. Which leads us perfectly into Phase 3, the dimensional stress test. We have our blueprint, and we have our materials, but now we have to rigorously prove the math doesn't just collapse on itself.
Let's walk through the incredibly satisfying puzzle of the central relation. On the left side, we calculate the dimensions of our new binding constant and mass. On the right, we do the exact same thing for Planck's constant and the speed of light. And when you do the dimensional math, they yield exactly the same thing. Length cubed times mass per time squared. It is a literal perfect dimensional match. If you're a physics nerd, this is exactly the kind of mathematical elegance you live for.
And we can run that exact same stress test for physical action, whether you calculate it as energy multiplied by time or momentum multiplied by distance. Plugging in the units from this new system cleanly reduces down to mass times length squared per time. Why is that so cool? Because that identically mirrors the exact dimensions of Planck's constant, proving absolutely flawless internal consistency.
Next up, let's look at the dimensionless constant, perfect balance. This right here is the ultimate climax of the mathematical proof, deriving a true dimensionless constant natively from within the formulas. That is the gold standard for a perfectly balanced system. Let's break down the structural constant, alpha sub O. The formula pits our structural constant in masses against Planck's constant and the speed of light. If we calculate the dimensions for the top half and then the bottom half, a beautiful thing happens. They completely cancel each other out.
And that brings us to this profound mic drop result, alpha sub O equals 1. It is a true dimensionless constant. What you should absolutely take away from this is that the osmomechanical system doesn't require any manual tweaking or artificial numbers just to balance its equations. It naturally resolves right back to 1, proving the system is closed, perfectly balanced, and structurally sound.
Finally, let's see how this goes beyond Planck units.
To really contextualize this massive achievement, we need to compare it to the historical gold standard of physics, Planck units. If we look at them side by side, the difference becomes super clear. Planck units are based purely on macroscopic gravity. It's a distant scale that's far removed from empirical, testable reality. Osomechanical units, on the other hand, are based on comprehensive structural binding right at the nuclear scale. They are up close to physical, experimental reality. The source material summarizes this entire achievement beautifully with this conclusion. The model is dimensionally coherent, possesses a closed unit system, generates dimensionless constants, and naturally reproduces action, energy, force, and length. Honestly, it survived the dimensional stress test with flying colors. We've looked at the blueprint, the materials, and the flawless stress tests of the Osomechanical theory, and it leaves us with an absolutely mesmerizing final thought to ponder. If the universe's blueprint is truly built on connective tension rather than a static geometry, what other massive mysteries of the cosmos are just waiting to be unraveled? It's a real game changer. Thank you so much for joining me on this explainer, and I'll catch you in the next one.